All right. So the thing is that I tried a lot of circuits. Probably one of the first circuit that I tried was this, and it didn't work. Also this one here, and also it didn't work. Oh, and a lot of others like this one as well. I don't remember this one. The not the 555. Actually, yeah. I used my counter to divide by 1110 from the probe of my counter, and I saved this file here. This one probably I tried it as well. I don't remember. This one is a classic, and it didn't work. I tried the numerous permutations. I tried this one, and it didn't work for the 32 kilohertz. I'm not sure for others, for other values, megahertz, but it didn't. So these are with NOT gates here, and also not worked with that. This is with an AND gate, didn't work. Another one with the NAND also didn't work. This was, it says here that it worked, but it worked in other projects. It kind of worked this time as well, but when I reset the circuit, when I took it out and when I built it again, it didn't work. So it kind of worked, but not really. And it didn't work with 32 kilohertz. It did work with 9 megahertz, but kind of sometime it did give me some errors, and it didn't want it to work at all, even with the higher frequency crystals there. This one is another circuit, and it didn't work with nothing worked pretty much. And this is back to the start. So I'm presenting here a lot of circuits I even had with op-amps. I use some op-amps. I use other NAND gates, I believe. I'm showing here this NAND gate and this guy. Yeah, these two are different. You see the input here are for all the three gates are linked to the positive 5 volts, while here both inputs are linked together. That's the difference between these two. They are looking similar, but not really. And they are both 7400 NAND gates. So these are all the circuits that I tried. In the end, my friend he purchased some crystals, and he tried it with a 4060 chip that we are seeing here. I already have this chip as well. Let me show you. Yeah, my IC list here. So 4060, where are you? 4060, here it is. It is a HC version. It is not an LS version. I know I have a ton of LS chips, as you can see. Also HC, HCT, but a lot of LSs. I know. And but this is HG. I know it's written here 74, but it's not from the 74 series, I think. So I have 10 of them, and I tried it this night, and it worked fine with this circuit. Here is a pin out, and this pin 9, CTC. It means external CTC, pin 9 here. Here it is, CTC, external capacitor connection. And here in, so the idea is that if you pay attention to the chip here, is having what is having pin 8. This is to the ground. Okay, pin 12, which is this guy here, is also to the ground. Okay, master reset. 11 is here linked to the crystal 11 and 10. You see, but this CTC pin 9 is nowhere here in the diagram, and I had a ton of errors. Well, yeah, I mean, it kind of worked sometimes. Then it stopped, and it was extremely unpredictable. Pretty much, I couldn't make the oscillator to be stable. When I was putting the power on, and when I was taking it off, after I was putting it on again, the oscillator was going nuts or not going at all. For the most of the testings that I did, most of the time it didn't start oscillating at all. You've seen this pin 9 here. Here in the diagram is nowhere mentioned. But I got the idea. Well, I read all these pins here. I read what they are doing, what they are, the meaning of them here in this table, and then I don't know. It just crossed my mind to actually put when I see that is an external capacitor here and nothing was showing here in the diagram. I was thinking, where the hell are the inputs? Which I started to identify all the inputs, and all the inputs, as you can see, all the Qs that is having are outputs, all of them. And they are not starting with Q1 to Q2. It's starting from Q3 3 directly. I don't know this chip very well. I have to dig it out. I have to get used to it. It's my first time using it. as you can see here in the diagram, that pin 9 is not connected to anything, so it crossed my mind to actually do something about it, because it is an input after all. It is external capacitor connection. I have no idea what this pin is, if it's, but I assumed it is an input. I link it to ground, and everything stopped, nothing worked, and that was the feedback that I got from this little experiment. And then I put 100 nanofarads capacitor to the ground, one pin, and another pin linked to this pin 9, and everything stabilized. Everything worked perfectly after that. Especially when I was putting power, when I was disconnecting the power and then reconnecting the power, everything didn't got nuts like before. Everything was stabilized and was counting by the second, as it should have been. Another thing I used, instead of this 4013, I used which one? 4027, this guy, flip-flop, which I have a ton of them. I have quite a lot of them, and they have a special connection. You have to connect them a little bit funky. 4027, let's see. 40, are you here? Yeah, pin out. No, this is only the pin out. Then 4027. Here it is. Yeah, why I want to show it because it is having a special wiring, and if we are playing it here, it's having this J and K to the positive and set and reset linked to the negative. And when you clock it, you see when you clock it once is outputting a 1 or a 0 here. It's flip-flopping. And that's it. This is what I wanted to show here, the basic wiring that it needs to be set, pretty much set up before doing anything else. And pretty much that's it about 4027 that I used in conjunction with 4060, and it gave me very good results. And this is it. All right.
What we are having here, it is an old circuit. Actually, I did test it before, but it didn't work. I did test in a couple of weeks, 2 or 3 weeks. I stayed only on this circuit to make it and to get the result that I'm having right now, that you are seeing here. You see, it is numbering by seconds, and here is displaying 1 hertz, 0, 1 hertz. And this is the circuit that I used. I actually used it before, but it didn't work. I will show you in a second approximatively how it worked before. And it's I modified this picture. I've added some extra information like CMOS binary counter 4060 this and this CMOS flip flop, and also this I moved this text here and dragged an arrow there to be more specific. Here is the modified circuit, what I marked with red, but I have this picture already. I have it, the circuit, I remade it in Proteus here. Exactly the same circuit. It is looking a little bit different, but it is exactly the same. And with every component that I used here on my, let me get back. So here on my breadboard, as you can see, you see 4027, and you cannot see very well this one. This is 4060. It's somewhere there. 74 hash 4060. That is a 0 there. Here, and that's the name of the chip. This is the original circuit, and this is the 4060 that I have 10 of them. But this guy here, 4013, I don't have it at all. But I have that 4027 that I showed you, and that's why this is the original. I leave it alone, and I remade it here with exactly the components that I have on my breadboard. This is the 47 that I have. Of course, this is the output actually on pin 1. Yeah, you see, this is pin 1, and this is the output, and the clock pin is pin 3. And you see here is pin 3 for the clock, and the rest is just the settings. These are the settings for the chip. You have to link set and reset to ground, and K and J to positive rail, pretty much. And on the output, I just put a simple resistor and LED. You can put anything. In my case, what you are seeing here, I put all these probes from all these devices. I have 1, 2, 3 devices, 4 devices, and also my oscilloscope here that I didn't use it. Here is the very easy to use it like this. You just plug it in. So I have only these four reading devices, pretty much. This is a counter. This is a frequency counter. This is a 4033 is the chip that I'm using inside it, 4033 counter. And this is a logic probe that I made it for a long time ago. It's a small one. I have a bigger one with 4 logic probes, but in this particular case, I don't need all of those and extra wires that are coming from that device. I only need only one single probe, and I have it. I can show you. Actually, this is the extra. I have 4 logic probes here, and they are disposed a little bit better, one on top, floating in the middle, and 0 on the bottom. It's a better design like this. This is having a funky design. I didn't think too much on it when I made it. Floating is on top, 0 is in the middle. So when this white LED is lighting up, is corresponding with this guy, which I put it on the positive rail, and then I dragged its other pin on that blue wire that is going exactly on the pin 1 there, and it's flashing in parallel with this 0. These two are working when it's 0, and when it's 1, the counter is actually counting. So when it's 0, it's not doing anything. Immediately after it's 0, when the 0 is off, immediately the 1 is on, and then it's counting 1. You see, if you pay attention, when this is off, this is incrementing. Exactly when this is going off, like zang, and this is incrementing 1 number pretty much. I can do it the other way. I can switch it. I can rotate it, so I can put it like this. I'll put it there, but it's a little bit confusing because for the color point of view, white, this is corresponding to a 1. It will increment exactly when you see when the positive is on. The counter is switching the digit, and this is lighting exactly in the same time, and is equivalent. This LED is equivalent with this one that is here, which is yellow. But this white 0, that these white colors are the same, you know, but not working in the same time. So that's why I switch it to a 0. I know it's a little bit of get using to it, but the scope. So I put it back to be in the same time with that 0 because of the same color. That's it. But all that is telling me, this LED, doesn't matter the position that is put in. What is telling me, it is telling me that is ticking, or the bit is per 1 second. That's its only reason there. And also this one, it helped me to actually see how fast everything is moving, and everything else, of course. These two are veterans for this circuit that I'm having here. I use them the most, these two, for all the circuits that I had, and I had like probably 20 circuits to make this motherfucker oscillate. What are you? Here you are. This is the 32 kilohertz crystal, which I thought, with all my heart, I thought is dead. When I measure it here, this is measuring, as you can see, I have some extra labels here, because in the beginning I had only its name, and it helped me immensely, this name, to remember what, to search for its picture on internet, pretty much, and to show it to others. But these two labels that I'm having here, I didn't have them until this problem arrived, because this is the frequency counter that I'm taking it from here, from this port here, not from here. Probably I can take it from here as well, because it worked from here as well. But I believe it's more correctly to take it from here, because I have some markings there. It says in. I know it's not very well showing, but it's an N there. It means in, and gnd, which means ground. So that is negative, and that is the input for the signal, pretty much. And I have this jumper, this green jumper. I know it's hard to see, but I have to switch it. There are 3 pins there, and the last 2 I have to switch it for this port here. And when I'm switching it to the other 2, the first 2 that are there, it will activate this port that I'm having here. Unfortunately, I have to fuck around with that thing. But the idea is that this is not counting less than 4 megahertz. So what I tried to measure here, this 32 kilohertz crystals, the circuit that is dealing with counting the frequency inside this device is not going less than 4 megahertz that I'm having here, or greater than 48. I thought it's 40, and that's why I made a mistake there. I put it 4 to 40. It was easier to, it's very easy to remember, but it's 4 to 48. I had to look and exactly copy this data from its data sheet from multiple sources. They confirmed me this numbering that I'm having here. For crystals, specifically for crystals. So is this module here for crystals, and this 1 hertz to 50 megahertz is also here and also here, but I made a distinction. This is for frequency counter general, and this is only for crystal reading. This is very easy, you see. It's made with matchsticks that I glued them together, and I put some pieces of cardboard, and then after that I glue these pieces very close together of metal that I prepared with solder, with solder. And here is the pins of this device here, this jumper, and these 3 pins of the jumper are going there inside. You see that jumper, the green jumper, and the last pin. You see, I have to move it there to activate this crystal tester, and it's actually saying there crystal tester. And I didn't really. I'm experimenting a lot with a lot of things, but sometimes you can get you can get some confusing results, and you think something else than it really is. So it's good to have a clear separation of the two. All I have to remember is that little fucker to move it when I have to test some crystals there. So that's the issue and the problem. And my friends from UK, they told me with half of mouth, yeah, maybe your megahertz crystals that you tested last time, maybe it's for megahertz and not for kilohertz like you have. And they were not sure either. And I had to, of course, I didn't I completely forget it because I did read all this data for this device, specific this device. I read it some time ago when I purchased it, when I buy it. I did get into all this data sheet. I read everything, but immediately after I read it, I completely forget some essential details. Like these are the most important details that you are seeing here. It's voltage that is working at its name, and the frequency. It's having two frequency or two modules that is operating, that is reading, and it's a very good, it's a very good counter. I don't believe it with all my heart, but I should put my all my trust in it because it is indeed a very good device to measure. Also, this guy. Although it is made by me, it is very sensitive. It did help me a lot in a very short time. Actually, it is less time than this device had a lot of more time to prove me how useful it is. This guy is relatively new comparative with this guy. And also this that you don't see it very much in my videos, but you should. Also this LED, this guy is everywhere. I'm using it everywhere because it's a good. It's an extremely good measuring device, especially the only problem with using LEDs for signal reading, and is moving around. Now when I'm praising him, you know. Okay, so the only issue that is having it must run at very low frequency, like it is running right now. It is absolutely fine, but if the frequency is too high, it will stay on all the time pretty much. So enough of the. So this is all the output reading. So I'm probing and I'm scoping the output of this flip-flop that I'm having here, that is receiving with this from this red wire that you're seeing here, is receiving some clocks pulses from this guy 4060, and here is its pin out 4060. And what these pins here are the pins. What these pins means, I made it by hand this time. Usually I'm making them on the printer here, and I have quite a bunch of them. You see, on the printer, but this time I made it by hand. And let me show you how it didn't work, how it was behaving when I hope I can replicate it good enough. And I hope I remember. Yeah, I believe it was pin 9. Okay, so pin 9 here. So I didn't had this capacitor on pin 9. So check this out. Here in the remade. This is my circuit that I'm having it on my breadboard there. I'm having this 10 nanofarads. I put 100, and 10 is better. It's closer to 1 second. Pretty much with that 10. But this is the original circuit, and this is the original circuit, and on this 4060 chip, we cannot see that number 9 with a capacitor, that number 9 pin with a capacitor to ground anywhere. We can see a 10 nanofarads here, but it's between the rails, pretty much. It's between the plus 5 volts there, rail, and negative rail. But this is for pretty much for stability, but I put it on in my circuit, and it's not stabilizing anything, because probably this is all this breadboard is acting like a capacitor already. That's why. So it doesn't have that pin 9 mentioned here at all in this circuit. So I had to pretty much to poke and test by myself everything, and that's why when I made this pin out of this chip, I put this list of the pins, what they mean. The rest of the cues that you are seeing there with the numbers are just output counters. You have to drag the output from something. So pretty much this is the Q13. From here, you see exactly like in this circuit 13. Where the fuck are you? Sorry. Yeah. Pin 3, which is Q13. So here it is, pin 3, which represents Q14, the output 13. It's a bit confusing, doesn't it? So this is pin 3 here, which is going into the input of this 4027 pretty much. So the output from here going to the input from there. And that pin 9 is CTC. This is the pin 9 there. Where are you? CTC. External capacitor connection, it means. C means capacitor, and R, you see, you have that. The next one, the pin 10 is RTC, and pin 9 is CTC. And RTC, external resistor connection. So C and R, this pin should receive a resistor, and this pin should receive a capacitor. But I did look on the circuit diagram how it's made inside, and actually these are outputs here, RTC and CTC. These two pins are outputs, but on a circuit diagram that they are providing inside the datasheet of the 4060, if you look a little bit down, you will see a circuit how it should work. I believe is very similar with this one that we are seeing here. The pinouts are very similar with this one, and there is having on pin 9 is having a capacitor. I forget what value is having that capacitor. I believe it doesn't even tell you. I don't remember exactly, but I myself, I had to play myself and figure it out, and I didn't see that circuit, and I did test it with my logic, with my head, I just poked around until it worked, because this is random what you are saying here. I will get to it in a second. But after I poke around and I figured it out by myself using a 100, and then I switched it to this 10 nano farads capacitor. Then I looked, I asked, I was talking about this chip with my UK friend, one single friend, who responded me all the time from United Kingdom, and he actually make it very clear to me that these two pins are outputs. And I looked after that myself, and yes, indeed, they were outputs. I believe CTC pin 9, it's an output from a NOT gate, from an inverter. And LTC is from a NAND or something. It's the output. The output of this pin 10 is going into the input of the inverter, and the inverter output is pin 9. I hope it's clear enough. And then I looked more, I started to read it and to pay more attention in the datasheet itself and scroll down. And when I got to that circuit, I noticed that a capacitor to pin 9. But I already, before seeing it in the datasheet, I already had made all the tests like an idiot, of course. And I had to discover it myself. And in this way, I am appreciating the value of this capacitor in the circuit. It is stabilizing enormously. I believe that capacitor in the circuit is on picofarads, I think. And I should actually listen to what is telling there in the datasheet and actually switch this 10 nano that I'm having here, which is in this other circuit. Let me get, if it's letting me, there, here. So this is the pin. So pin from pin 9 to ground, pretty much. You see here. And master reset is this pin 12 is directly to the ground. So I will have to test, because right now is not actually 1 second exactly perfectly, and it was even more delayed with the 100 that I put it there. So I switched it to 10, and it was close enough to 1 second with 10. So probably I will have to switch to another capacitor, other value, to get even closer to 1 second. But as you can see, it's extremely unstable right now. And this is counting 8 hertz here. Come on, there. And this is showing a rapid pulse, but I hope I can make all the tests that I did before. So if I'm taking the power, so right now nothing works here, right? So if I'm putting the power, you see how fast, yeah, it's kind of stabilizing. So for a second, it's getting very, very fast, and then is stabilizing at 8 hertz. But it wasn't the case like this at all. Probably all these devices that I'm probing on this chip probably is affecting this other chip. I have no idea why, but most of the time it didn't work at all. Nothing was counting, nothing was moving, oscillating. Nothing was oscillating here at all. And I was thinking, is this problem here on this side of the circuit? But I track it down, the problem here. I track it down here. Of course, I had to do this in a couple of days. Actually, it took me like 2-3 days after I built this circuit, and I stayed with it on the table that you are seeing here. And I poked around. I tested multiple times, many times, until it worked. And sometimes it was working, sometimes it was not working at all. It was not counting anything. So I had this problem for a very long time, not oscillating at all. And for every circuit that I did, including this one with 4060, and I had multiple frequencies. It was randomly switching either too fast or too low. Like in this, without this capacitor, I even got it working at 1 hertz, like you've seen me before. I don't know why, but it worked. And then when I restarted the circuit, like I did, like I'm doing right now, when I'm plugging it out and plugging it in back again, it was again random or stopping at all. Right now, it doesn't want to do that for some reason. I don't know what I did before, what stage the circuit was. But it was pretty similar with what I'm having here. I didn't do too much. It is having some sort of memory because of this, and it's very, very extremely devious. And I had to actually short. Of course, I plug it out. And I shorted everything. I shorted this pin here, this resistor pins here, this resistor pins, these two capacitors that I'm having here. Its pins. I'm shorting them like that to eliminate any kind of possible capacitance remaining around or inside the device. Also the crystal itself, I took it out. I shorted its pins. I have to do it with one hand right now, but I'm explaining it what I did. So I shorted pretty much like that. I shorted its pins with a piece of metal, of course. Also I shorted the positive and negative pins, these two pins as well. And let me actually, because this is to negative here, to short it like this. So pretty much I shorted this pin with that pin, pretty much. Let's see if it's changed. No, it didn't. But in my case, all my tests that I did, it did change a ton, a lot. It changed the behavior. Either it was very close to 1 hertz, randomly, like right now is 5 or 4 It did change a little bit. It was 8 hertz, and now it's changed for 5 or 4 hertz. Let me actually do it like this to restart it to maintain a little bit this result, not to turn off too quickly. So so now it's extremely now it's stable for some reason, but it wasn't stable at all, and I had to fight with it a lot, and then I figured it out. I have to insert this motherfucker here. I discovered this is the key for success. But even with this capacitor that I'm having here, now it got to 1 hertz, exactly like in the diagram that I'm having both of them. So so this circuit is exactly like the original circuit that I showed you there. And with that 4013 that I don't have it, I had to replace it with 4027. Let me actually show you. Let's count together the seconds a little bit. Let's count together the seconds. You will look here on this digit when it's changing in parallel in the same time with. Yeah, and I got extremely lucky right now that they are in the same time, exactly in the same time. You see, it's 00 on my seconds on my watch, and that has quite on point. But it is a slight delay. I did observed. If we are staying, you will see the red markings are the red digits are going a little bit faster. I believe a little bit faster. It will. No, right now it's pretty stable. Right now, for some reason. Unbelievable. But it wasn't as stable as it is right now at all. It was going in the woods quite quickly. After 10 seconds or 20 seconds, after 10 or 15 seconds, it was visible going nuts. You know, right now it's quite stable, incredible stable, and incredible on the same pace with my clock, with my second from my watch that I'm having. So this is my way of comparing those two. Right now I had an incredible luck. Incredible, it's pure luck this that I got the exact timing seconds. You see, it's exactly the same seconds. Unbelievable. This is very cool. The exact same seconds on both of the displays. Absolutely, and they are synchronous, not one in front of the other, because they are two different systems pretty much. They're running from their own power source, and if you power them, yeah, I kind of stay here like 1 minute, and it didn't decalate too much. It's actually pretty on point. It's pretty good. It's counting extremely good. Maybe tiny little difference. Maybe I'm not completely sure, but it's pretty bang on. It's yeah. Oh, my hand. I had to keep it in the same position all the time, and it's hurting right now. Okay. So it's pretty on the second right now, but I didn't get this result. So I was thinking to change that capacitor into a something is touching here and it shouldn't. Probably I'm loading all this stuff that I'm checking with them here are loading the circuit and is stabilizing it. Probably, I'm not completely sure. But the next step, absolutely, and I will build it because this is a very easy to build circuit. I will have to make a cardboard with exactly this circuit that I'm having here and test that with everything that I'm having here right now, with this device, this, and also I will include the LED on the board itself, directly there, and also some test points or something, probably a single wire that I will plug it into this breadboard here from that cardboard with the circuit, and then measure there, and I should get the same result that I'm having here. Hopefully, I will not get errors, but if I will get errors, those errors will be exactly as I experienced before getting this absolutely incredible result that I'm having right now. Let me take out the you see it's going nuts here. Let's see, the frequency is not that high. It's 44 hertz. Yeah, also you can see the LED is flicking, so it's very it's actually here when I was touching this wire, I believe it was in air. When this wire was in air, I guess probably it was when I was holding the wire. Yeah, you see 50 hertz. So it's measuring pretty much my internal oscillations that I'm having, although this is getting into the input and it's processed inside it, and it should be divided by 2 pretty much. So pretty much I should have 100 hertz, and this is showing 50, like 100 divided by 2 in its output. I'm not completely sure why it's showing 50 hertz there when I'm touching this wire here. I know for sure I am receiving 50 hertz from the mains that I am surrounded in my room, at least here in without interfering with my hands there. It's actually lower frequency, you see, 40, and it stopped. You see, finally it stopped. So yeah, so you see I'm having but this is uncoupled from there. But it was behaving like this, like you are seeing here, with everything in place actually, and I exactly as I'm putting it right now, and now it's stabilized and it's back to 1 second. But it didn't. It was random like that. I kind of made. I reenacted. I replayed the errors that I was having, and it was like this for a very, very long time. Probably the holes that I'm having here, the contacts are not making actually contact. It might be, but I do feel when it's, it might be in the interior of this breadboard, using it so much with the diverse components, the pins that are making contacts there, not actually making contacts anymore. Who knows? Who knows? But I was getting exactly this kind of behavior that I'm having right now. But this crystal oscillator was in other places mounted, and this circuit also, it was somewhere else placed. Here, there, but not here. This is the last. I didn't use this part at all of the breadboard. So maybe this is more virgin part side of the breadboard, and this two fucked up holes, probably they are not making contacts, and that's why I was getting that erroneous behavior, like the crystal was not inside it. I was getting even higher frequency. I was getting like 1 kilohertz or something, 1000 hertz there. I was getting extremely fast and extremely random results until I managed to calm it down, to make it as you are seeing it right now. It was a very long fight with this circuit to make it work, with a lot of circuits actually, not this particular one that I'm having here. This is the winner circuit that my friend from England, he tested it in his side of the world, there in his England, and he told me that his circuit with the 4060 that is using is working absolutely fine. He didn't use this 27 that I'm having here. He used I believe exactly like in the circuit diagram, 4013 or something it was, no? Anyway, and he told me, yeah, it's working perfectly from the first try. And I was, what the fuck? Why my circuit is busted? And I concentrated more on this circuit because I got the approval from my friend, the certitude from my friend that is working. And if its circuit worked, I completely concentrated on this 4060 circuit totally. I concentrated, and it didn't work from the first try at all. In my case, for many tries, it didn't work. I am insisting on many because it was like probably 30 tries or something like that, 20-30 tries, and after that it gave up and starting to work normally. I have no fucking idea why I'm getting all these errors. This is not the first circuit, but for the other circuits that I had before, I'm getting a lot of errors. And I am always suspecting this breadboards always, but for the reason of frequency interfering. That's why this is what I'm thinking, that they may interfere, but maybe it's a mechanical problem with them. I don't know. I'm speculating highly. I'm highly speculating right now. But that's the history, how I managed to stabilize this circuit that I'm having here. Is working absolutely fine. The next step is to make it on the cardboard. Yeah, like this, on this kind of cardboard. And I'll have to cut it down to make the sketch and everything, and probably I will show the process as well. And I will duplicate pretty much this circuit that I'm having here. Make abstraction of this. This is not part of the circuit here. It's just another test that I left it there. I hope it's not too confusing there. So pretty much this is it about this subject. It was a hell, complete hell to build it, because I tried many, like I said, many chips with NAND, many circuits with NAND gates, with NOT gates, and none of them worked or at all. It didn't oscillate at all, or if it was oscillating, it was way out of control. It was either randomly oscillating when I was resetting the circuit, randomly working sometimes at higher frequency, sometimes at a lower frequency. It didn't have any meaning. I couldn't. It was wild. I was getting a lot of wild results, and it was very extremely frustrating. But I am used to get this kind of extremely bad results. I'm used to them, and I am used to overcome them. And I do trust my logic. I do trust other guys' logic. Some circuits on internet, I do trust them, and I do trust my friends, especially the English guys that I'm talking with. I have 2 friends in England, and I number them on my fingers here. A guy from electricians forums, Mr. Marconi from England, and another guy from AAC forums. All about circuits forums is AAC. These 2 guys are helping. And I had an American one, the third one, a couple of years back. And that guy was absolutely gold. He helped me a lot with very cool stuff, with a remote control circuit. It was cool, a very cool guy. But he just give up on my projects. I'm having too much stuff here to deal with. I'm trying too many things, and probably, yeah, it wasn't on my frequency. But these two guys are very, very close to my frequency, and Mr. Marconi is kind of on my frequency, but the other guy is literally on my frequency. We are talking on the same line of thought, and we are making stuff working. That's the most important thing, and that's why it's good to have a little bit of friends, to talk with somebody. I'm giving this as an advice to anybody that is looking on my videos. It's good to have friends. It's good to talk with somebody on the problems, and I had a ton of them, and I didn't discuss all of my problems. I only discussed the most important ones that I had, but not all of them, because it was crazy, and I did try my best to solve them, and I did, and I'm very extremely proud I did. Another point is that I have to go back to AliExpress. But first of all, I want to make it on the cardboard, like I said already, that I mentioned. So after I will build it on the cardboard, exactly this circuit, I will replicate it on cardboard and test the shit out of it. And if it will behave like it is right now, then winner chicken dinner, like Mr. EV blog is saying. No? If that circuit will work, then I will go back to AliExpress and pay them back the enormous sum of $1.50 or something. They did give me the money back on this, guys. When I report them as faulty, as not working, I even showed them the video that I made. But they are just commercial guys, and they don't really understand what is going on in more depth, like my friends that I had with telling me, be careful, you are checking only the megahertz, and what you are checking is kilohertz, which is another beast pretty much. So I will have to get back to AliExpress website, and because I am a very poor Romanian, I will be also very correct and give them this little sum back. It's not about the money, it's about the trust, and I trust them. They delivered every time I did purchase a lot of good stuff from them, actually. Because of AliExpress, I learned a lot. Because I could buy a lot of stuff, very, very cheap stuff from AliExpress on eBay, but eBay is not anymore the winner right now. The king of the hill, AliExpress is the king of the hill. Unfortunately, eBay was for a very long time, for many years, probably 10 years. eBay was the king of the hill. Extremely low prices, very, very good. But now they shit the stick, and the AliExpress came from the second place. Now they are on the first place, the king of the hill. And I will have to. I do trust them, and I do appreciate their effort and what they are doing with this low, cheap prices and electronic commerce that they are doing. And they have my respect, and they must be praised more often, probably. And yeah, they are good guys. And it's about trust, it's not about money, especially at this sum, which for me is quite a lot sum. Even $1 is high enough in my money, if you are converting in my money. But because where I live is a very poor region, very, very poor. Not only me, everybody in this city is quite poor, and it's shit. Life is shit here. Trust me when I'm saying it. Life is extremely shit, and more than this, there is no chance in hell to get better, to make it better, because the people are just idiots. They are peasants. They are unbelievable, stupid, and retarded. Probably a lot of bunch of them are retarded, and instead of being institutionalized, they are left free on the streets. And crazy as fuck, and crazy, hospital crazy, not because they are doing one thing, one crazy thing in 1 month. They are doing it a couple of times per day, every day. So that kind of crazy. So no way. It's shit. It is shit. Where I live is just a hole in the hell. Is a special hole in the hell here. All right. For many reasons. I'm not sure how is in other places in this world, but here is shit as until your neck, until your chin. It's full of shit here. Socially, economically, the humans are not really. They are just incredible. Nah, you cannot. I cannot get easily. I do have a lot of friends, actually. I'm not a single person, but I do have a lot of friends. But most of them are in the world. They are not one single guy. One single friend that I had are not living in this fucking city anymore. They are all they move away, and they are more smarter than me from this point of view. And it will come the time I will go as well from the good life that I had until now. All right, that's it for this part. I hope you liked my projects, and I hope one last point is that this project, this 1 second circuit that I'm testing it for probably 1 month or 3 weeks already, is for this device that I made. This is the counter, and this 1 second, specific 1 second cardboard or module will be inserted here on top of this, and its output will be linked somewhere here. I don't know where. Probably I will have to make another switch for it somewhere to switch to 1 second or the rest of the functionality that I'm having already here. I actually use this prototype device that I'm holding in my hand right now instead of this, but I prefer this because it's extremely small size. This is having a lot of functionality, but it's too big, and yeah, I do prefer that one for the moment being. But in the future I will use it more often, that big thing, and show it off more often, because it's a very, very cool thing. I really like it. I really like it. I also like this guy because it's extremely compact, and I love it. All right, thank you very much. I really hope you liked, and I really hope you learned something with me here. And all right, see you later on the next progress, when I will actually do something about it, about this circuit. All right, I'm very extremely happy that I managed to make it work at this level that I'm having it right now. I'm extremely happy. And I'm also extremely glad and extremely happy that I escaped from the hell that I was having until here. All these 3 weeks was hell. Nothing worked. Absolutely nothing worked. And I tried everything. I tried many circuits with all these chips, and even more than that. This is what they remained on my table here. And I was extremely sure these are busted, absolutely busted. But it looks like they are fine. Absolutely incredible. Cool. And I have another chip that I bought it specifically to make some tests with it, and I didn't make anything because nothing worked, but is in plan. That chip is not here, but that specific chip should, theoretically, in my mind at least, should replace these 2 chips, and only with 1 chip I should get the output. So I will have to deal with it, but later, more later than what I'm having here. All right, bye bye, and see you later.